Hello everyone. In this second part, we are going to study the ordinary differential equations. This part consists of 4 chapters. First chapter, we study the series solution of linear equations. Second chapter is the Laplace transform. Third chapter is the systems of linear first-order differential equations. Last chapter is the plane autonomous systems. First chapter is series solution of linear equations. First section is a power series. Second section is a solutions about ordinary points. Third section is a solutions about singular points. Last section is a special functions. Using series solutions, we find the solutions of our differential equations. In this section, we study the Bessel's functions and the Legendre's functions. First topic is the power series. A power series in x minus a is an infinite series of the following forms. A power series centered at x equal a, so this means we expand the functions using the x minus a. Coefficient of the power of the i's is c sub I. We sum up the infinite number of terms c sub I times x minus a to the i's. It is important to determine interval of convergence, the range of the x when the function is convergent. To determine the interval of convergence, we use a ratio test. In the ratio test, we compare the two sequent terms. So if you write this equation, it's sum of the I starting from 0 to the infinities. This is d sub I. The d sub I is a single terms is expressed as c sub I times x minus a to the i's. In the ratio test, we compare the two terms d sub I and d sub I plus 1. Ratio is a d sub I plus 1 over d sub I. This ratio need to be less than 1. Then the power series is a convergent. So let's look at the ratio test. As I explained, we take ratios d sub I plus 1 over d sub I. Take absolute quantities. This is equal to the limit I to the infinities c sub I plus 1 times x minus a to the I plus 1 over i's term is a c sub I times x minus a to the i's. So this part is exactly equal to the x minus a. And there is no I dependence, so we can move these terms outside of the limit. Absolute value of x minus a times limit I approaching to the infinities and the absolute quantity of the c sub I plus 1 over c sub I. If this quantity becomes a capital L, if the capital L is less than 1, then power series is convergent. Convergence of power series need to be determined using the ratio test. Then you might wonder in the L equal 1 to find out the interval of convergence, we have to check the each end of the intervals. Okay, this is the end of the first session.